Okay, Bismillahirrahmanirrahim. Okay, so this is they have not numbered the question, but this is May June 2002, question number 5. Okay, I hope everybody is following with me. I'm on page 4 of this worksheet. 20 cm cube, a sample of butane, the formula of which is C4H6, is burned in 150 cm cube of oxygen. This is an excess of oxygen. What does excess mean?
More than required.
Very good. Yes, more than what is required. Okay. How do we know what is required? How do we know what is required?
By calculating the moles.
Okay. That's an incomplete answer. That's an incomplete answer. Yes.
By calculating the moles of the atoms.
Calculating the moles of the atom. Again, incomplete. Beta, remember in one of the classes I gave you an analogy and I tried to explain you this excess thing, this excess. I hope this is straight.
Oh yes.
Yes, what was
Miss,
it? Do you remember?
The burgers one.
Very good. Thank you. Very good. Yes. So if, for example, I have, let's suppose I have two buns, okay, and only 2 buns, and let's suppose 3 breads. Okay, these are 3 breads. Okay, now for a sandwich, कैसे बनाऊं मैं इनको? Okay. For example, this is breads and these are these are kebabs. Okay, I have only 2 kebabs. Okay, now these can be, cut into halves, So how many sandwiches can I make out of these?
1.5.
Two.
Yes, two, only 2, because I have only 2 kebabs. Okay, I have only 2 kebabs, so I can make only 2 burgers or sandwiches, whatever you wanna. Only 2. Now, if I have 3 kebabs, okay, these are kebabs, and I have only 2 breads. Now, how many burgers can I make?
2.
Again 2. Again 2. This was bread. Okay, again 2. So that means this is the limiting factor, or this is this is called a limiting factor, and this is called bread is a limiting factor here in this example, and kebabs are in excess. So one will be left. So this is in excess and this is the limiting factor. Okay, and it is usually it is always the limiting factor which decides the mass of the final product and also the rate of reaction, how fast the reaction would be. It is always the limiting factor. So you can see here I'm getting 2 burgers because I have 2 kebabs, because kebab is the limiting factor here in this example. And here the limiting factor was bread, and so again I was having only 2 sandwiches or whatever, because the limiting factor was, the bread was only 2. Bread was the limiting factor. So it is always the limiting factor which decides the mass of the final product. Okay, whatever is extra is in excess. Okay, so this concept should be clear. Okay, so now in this equation you have butane and oxygen is in excess. Oxygen is in excess. Okay, also pay attention to the equation. The ratio is 2:11. 2:11. That means for 2 moles of butane, 11 moles of oxygen are required. 2:11 is the ratio. Now the question is, the first part is asking what volume of oxygen reacts. Okay, they have given in the question the total volume of oxygen, which is 150 cm cube, but that is excess, meaning it also includes extra oxygen. But out of this 150, how much does react? How much does react out of this 150? So how will we calculate that? So we know the ratio is 2:11:8. You can see my camera, right?
Yes, miss.
Spotlight. I am.
Yes, miss, we can.
Okay. Okay. So, so now both of these are gases. Okay, both of these are gases. How do we find out the number of moles of gases? By dividing its
Number of moles equals to volume over 24.
number of moles is equal to volume divided by 24.
24.
Right.
Yes, miss.
Right. Okay. So yes. So do we have the volume of this
Yes,
butane?
miss.
Yes. We cannot use the volume of oxygen from the question. Why? Because it has excess. Okay, the question is asking what volume of oxygen is reacting. Of that 150, how much is reacting? Okay, so using this ratio, whatever butane moles we get using this ratio, because for every 2 we need 11 moles. So whatever the moles of butane will be, how much moles will of oxygen be required? Okay, we will use the ratio, but for that we need to first find out the number of moles of butane. And how can we find that? By dividing its volume. Where is the volume? 20 cm cube divided by
24.
Yeah, but remember that is
20 is centimeter cube, so we'll divide it by 1,000 first.
yes, number of moles of butane. So I will, yeah, you can use the formula. Okay, let's use the formula. Okay, because I feel you guys are more comfortable with the formula. Is that
Yes,
right?
miss.
Yeah, but you know what? I am not. I don't know why, because I tend to forget the formula. Okay, but anyway, I'll do it for you. Number of moles of butane is volume. So your volume should be in the same unit. What unit do you want? dm cube?
dm
Miss?
cube and decimeter cube. Yes,
Okay, so then
Mi-
you will have, so in the question, the volume of butane is
centimeter cube. Cube is
20 cm cube. So how much is that in dm cube?
0.02.
Divided by 1,000.
0.02.
Yeah, 0.02. So remember to do that. Okay, because you're
Miss?
using 24 and that is 24. So both the units should be in dm cube. Yes.
I was gonna ask, like, for example, in exams we have like in a question we have one formula, 1 mark for the formula, and 1 mark for the actual question. So if we use the ratio method, so 1 mark will be cut.
No. I don't think so. This marking distribution, I think, is for your school exams, but in IGCSE, I don't think they have this. But if there is, you can come up with the formula. You can come up with the formula even from ratio. I have done this. Look at this. This is the ratio method. And at the end, what do I get? I am doing the exact same thing, 0.02 divided by 24. So when you get here, you can always write down the formula. This is the volume of oxygen divided by the molar volume, which is 24 dm cube. Okay. So yeah, okay, if they have allotted 1 mark to the formula, you can write down. But for some reason, I get confused. I cannot remember. This makes sense to me. But anyway, okay. So when you do this, 0.02 divided by 24, you get 0.0008 moles. So that many moles of butane. Okay, that many moles of butane. So now we know the moles of butane that reacted. Okay. Now, once we know the number of moles of butane that reacted using this ratio of 2:11, we can find out the number of moles of oxygen that reacted with it. So for every 2 moles of butane, 11 moles are reacting. So using that ratio, we find out that 0.0044 moles of oxygen reacted. Moles of oxygen reacted. Okay, there were many more moles of oxygen present available, but only these many reacted. Remember, oxygen was in excess. Okay.
Yes.
Yes. Okay. So the volume, so the next question, yeah, okay. So the volume of oxygen that reacts, this is the question they asked, right? So once we know the mole, number of moles, we can divide it by 24. Why did we divide? Again, using formula. I use the ratio method, but okay, let's use the formula. Formula is, what is it? Yeah, number of moles is equal to volume of oxygen, volume of gas divided by 24, right? So number of moles is 0.0044, and you multiply that by 24. When you multiply that by 24, you get the volume of gas. So I multiplied the number of moles by 24, I got the volume of oxygen that reacted. So it is 0.1056 dm cube. Is everybody with me? Did you understand?
Yes, Miss. Miss, I got 0.109.
Why?
Because 0.0083 over 2 multiplied by 11, I'm getting 0.00456, and then multiplied by 24 and get 0.109. Yeah.
Yeah, okay, maybe there's some problem with my calculator, maybe. So yeah, okay. Okay, 1 or 2 decimal places error is forgivable. That's okay, but I'm not sure. Maybe there is some problem with my calculator. Okay, I don't have my proper calculator these days. Okay, so part 2, but you get the, but you understood, right?
Yes,
Did,
Miss, we got the method.
yeah, did all the 12 participants in this class understood? Did they understand?
Miss,
All of you? Yes.
Miss, can you please explain the first part? I don't get it.
Which first part?
The
Which
volume
part?
of oxygen that reacts. And Miss, I want to ask you that when it says excess of oxygen, how is it different from when it gives the amount of oxygen?
See, there are, listen, first of all, the question might mention that this thing is in excess. In this question, they have already mentioned it themselves. Okay. On the other hand, sometimes they ask you which one is in excess. So how do you find out? If you have the equation, you find out the number of moles of the other reactant, the other thing that is reacting. Okay, if for example we did not know if oxygen was in excess or not, for example, what would we do to find out is that we would find out the number of moles of this reactant, or even the products, whatever is available in the question. Okay, what if you can find out the number of moles of the others, then you look at the ratio. Using the ratio method, you will find out the number of moles of oxygen. I will take out the number of moles of oxygen. Okay, then again I will multiply that by 24 to find out the volume that is exactly participating in this reaction, and then I will compare that volume with the volume given in the question. Is it less? If it is less, then that means if the answer that I got is less than the what they have given in the question, then that means that this oxygen was in excess, because they have given more than what is required. And if what I'm getting is more than what they have written in the question, then that means oxygen was a limiting factor. Did you understand? I mean, it is less than what was required exactly to participate with this. Did you understand? Did you understand? Yes. So you have to know the number of moles of other things in the equation, whether reactant or product, and then using the molar ratio, you will find out if what you have is more than what is. So what you will calculate is what is exactly required. Then you will compare it with other things that you have in the question to decide if it is an excess, or is it less than what is required, or is it more than what is required. Okay, so the volume of oxygen that reacted was this. Okay, and how much is it, how much is given in the question? 0.15 dm cube is given in the question. 150 cm cube. is the same as 0.15 dm cube. So in the question, they are saying that we have 0.15 dm cube of oxygen, but only 0.1056 dm cube reacted. The rest was left at the end. The rest of it was left at the end. Okay, part 2, what volume of carbon dioxide is produced? What volume of carbon dioxide is produced? Now, we know the molar ratio, 2:8, right? According to the equation. We know the number of moles of butane. We have already calculated.
Miss,
Yes?
when I'm calculating the volume of oxygen which is reacting, mine says coming 0.044. There's not one more zero. I think you wrote one more zero. That's why when I'm calculating the carbon dioxide which is being produced, it is 1.1056.
I didn't understand you. What were your moles of oxygen? So, Sidra? Listen, I need a calculator. Can I have a calculator, please? Thank you. Yes, I am unmuted. Okay. Okay, I'll try to get hold of my calculator and see what's wrong with my calculations. Did you do this? These are 3 zeros here.
Yes, miss.
3 zeros, 8. Okay, let me do this. 0.0008 into 11 is equal to this, divided by 2 is equal to 1, 2. Yeah, it is 0.0044. It's 0.0044. My answer is correct according to my calculator. Okay.
Yes,
And then
miss, the same for me.
yeah,
I got it.
multiplied by 24 is equal to 0.1056. Yes. Okay. I don't know why you are getting a different answer. Okay, let's move on to the volume of carbon dioxide produced. Now, now there are different ways of finding out the volume of carbon dioxide. Now, you know the number of moles of oxygen as well as you know the number of moles of butane. You can use either. You can use either one of them. You can use the ratio of 11:8, or you can use the ratio of 2:8. Okay, so I use the ratio 2:8. Okay, because you know this we calculated ourselves. Yeah, no, but yeah, okay, you can use either one of them, you will get the same answer. So 2:8. So the number of moles for butane were 0.0008, and so the using the ratio method, the number of moles of carbon dioxide produced are 0.0032 moles of carbon dioxide. Did you get it? Did you get this?
Yes, miss, I got 0.0032.
Yes.
33.
Okay.
I got 0.0033.
Yes. Okay. And if yes. Okay, let's move on. So the volume of carbon dioxide, so that is the number of moles. We will multiply that by 24 to get the volume. Okay, one mole of any gas has a volume of 24. So how much will be the volume of these many moles? So you simply multiply the number of moles, and you can write down that formula. Okay, I'm not writing that formula again and again. You can write that same formula, which is the number of moles of a gas is equal to the volume of gas divided by 24. Okay, so you will get this. So at the end of the reaction, what gases are we left with? This carbon dioxide, which was the product, because water is in the form of liquid according to the equation. So we are not concerned with water. At the end, the third part is asking what is the total volume of gases left at the end of the reaction. So we have carbon dioxide and we have some extra oxygen which did not react. Okay, so what have I done? Volume of gases left at the end is equal to the volume of carbon dioxide plus the volume of oxygen left unreacted. Okay, the volume. So I will have to calculate the volume of oxygen that is left unreacted. This is the total volume that was given in the question. This is the volume that reacted. The difference will give me the volume that is unreacted, left behind. Then I added that to the volume of carbon dioxide, which we had calculated here. Okay, I added them. And so this is the total volume of gases at the end. Yes, Zainab?
Miss, that was my question, that at the end of the reaction, isn't the carbon dioxide there at the product side at the end? So why
Yeah.
did you took the oxygen with it?
I didn't. Oh, sorry. This is carbon dioxide. This is not oxygen. Sorry. This is a mistake. Sorry. This is carbon dioxide. Oh,
It is oxygen, miss.
oh yes, yes. You are confusing me as well. Yes, this is the volume of oxygen which is left unreacted, because remember oxygen was in excess. And so what was your question again?
Miss, they asked us that what were the total volume of gases left at the end of the reaction, but there was only one gas left at the end of the reaction at the product side, carbon dioxide.
No, there are two gases left at the end. One is oxygen, which is left unreacted. The other is carbon dioxide, which is produced, both.
So
Did you
how will we calculate it then?
by adding?
Okay,
Simple?
miss.
Yeah, by simple adding.
Okay, miss.
Yeah, luckily they did not ask how to separate them. Otherwise, you would be in deep trouble. Okay,
Yeah,
so
yeah.
yeah, just simply add them. Okay, okay. Now part D. Calculate the mass of water formed when 9 grams of butane is burned. The mass of 1 mole of butane is 54 grams. From the above equation, one mole of butane forms 3 moles of water. So if you look at this equation, how did they get this 1:3 ratio? Calculate the mass of water formed. Now they're asking you to calculate the mass of this, the water at the end that you have in the equation. Okay, the ratio is 2:6. The ratio of butane to water is 2:6. But they have simplified it. How? 2 1s are 2, 2 3s are 6. Right? So 1:3. So say they have simplified it, and they did not even ask you to do this yourself. They have themselves mentioned in the question that 1 mole of butane is forming 3 moles of water. Just simply use that ratio. So what did they say? To calculate the mass of water formed when 9 grams of butane is burned. Okay, so first we have to find out the number of moles of butane. Now this is the same reaction, but this is a different reaction, I think, in which they have themselves mentioned that the mass of butane is 9 grams. So it's easy, number of moles of any substance, that same formula, write down the same formula, number of moles is mass divided by the molecular mass. So mass of butane here is 9 grams multiplied by the molecular mass. They have already mentioned in the question, it is 54 grams. You divide 9 by 54, you will get 0.1667 moles of butane. So these many moles of butane are participating in the reaction. Okay, now how many moles of water? Now the ratio comes in. Now we will use the ratio 1:3. For each mole of butane, 3 moles of water. And so 0.1667 moles of butane multiply by 3. You multiply 3 by 0.1667. That the answer that you get will be the moles of water produced. Okay, and so mass, number of moles multiplied by the molecular mass. You can write down the formula if they have allotted 1 mark for that. Number of moles into molecular mass will give you the mass of water. Grams. Okay, any confusion? Any question?
No, miss, no confusion.
over there, when you wrote 3 into 0.1667 over 1, that is our x, right? Which you have to find. Like you wrote overall.
X? What? Yusra, can you please repeat your question?
Miss, I'm saying that where you have written 3 into 0.1667 divided by 1, that
Yes.
is our, right? That is the moles that of water that we have to find. Like
Yes.
instead of x, you wrote the overall, the whole thing.
Yes.
Okay.
Yeah, this is the number of moles of water, the mass of which we have to find. Just simply multiply by molecular mass of water, which is 18. And so the mass that you get is the mass of water. Okay, is there any question? Okay, let's move on. Next question.
Miss, can you
Yes.
explain the part 2 of this question?
Sorry?
Can you explain the part 2 of this question? How you calculated? I don't understand that.
Volume of carbon dioxide.
Yes, miss.
Volume of carbon dioxide. So I just use the ratio, same ratio method.
Miss, I cannot see your notebook. Yeah, now it's better.
Yes. So I am using the ratio method. Okay, I am using the ratio method. So I know the number of moles of butane and I know the ratio, it's 2:8. So number of moles of butane are 0.0008. Now you understood, right, how I calculated the number of moles of butane, right?
Yes.
Right. So just the ratio method, I multiplied the number of moles by 8, they divided by 2. Whatever I got, that many moles of carbon dioxide. So for volume of carbon dioxide, I multiplied that number of moles by 24 because 1 mole of any gas occupies 24 dm³. So if I have a number of moles, I will just multiply that by that value 24 and I will get the volume of carbon dioxide, the whole gas.
Oh, okay, miss. Thank you. I get it.
Now you got it?
Yes.
Okay. Is there any other question? Does anybody else have any question?
Miss, can you just for a second show me the third part?
Third part, volume of gases left at the end?
Yes, miss.
Okay. So it starts from here. Volume of gases left at the end is volume of carbon dioxide plus. I have shared this. I've cam scanned it and I've shared in the group. Are you copying? You
Yes,
can.
miss.
Yeah, beta,
Because
it's
the cam
already.
scanner is not opening for me.
Sorry?
After the morning, it's not opening for me. The cam scanner one, the PDF you've sent. Just a
Okay.
second.
Okay. So volume of oxygen left unreacted is 0.15 minus 0.1056, which is the volume that was produced. Sorry, the volume that oxygen that reacted. Okay, I think we should move on now. We're short of time. I want to do more questions
Yes,
today.
miss, we can.
Yeah, okay. Now, the next question is, let's move on. Okay. Each tablet contains, now we are still on page 4. Okay, each tablet contains, this is May, June 2003, question number 2. Each tablet contains the same number of moles of calcium carbonate and magnesium carbonate. One tablet reacted with excess hydrochloric acid to produce 0.25 dm³ of carbon dioxide at RTP. Now, hydrochloric acid is excess. Excess meaning more than what is required. Okay. So, and they have also mentioned that one tablet has equal number of moles of calcium carbonate and magnesium carbonate. They have the same number of calcium carbonate and magnesium carbonate. And the carbon dioxide, which is produced combined. Now, because each tablet has both, therefore, and has 2 different substances, they have shown the equations separately. I have not written down the equations here, so please refer to the question. So they have written 2 equations, right? But they are both taking place inside the same, they're both being carried out by the same one tablet. Okay, and so the carbon dioxide which is being produced is combined of the 2 reactions. You understand? Carbon dioxide is being produced by both these reactions, and both these reactions are taking place by 1 tablet. So Zainab, you please pay attention, because you were asking this question in the group today, and I said that I cannot explain in the message. Okay. So now part 1 is asking us calculate how many moles of calcium carbonate there are in 1 tablet.
Miss, can you repeat that what you told about the carbon dioxide about it?
So carbon dioxide, what, you know, the total volume of carbon dioxide that they have mentioned in the question, 0.24 dm cube, is the total carbon dioxide from both the reactions, one with calcium carbonate and the other one from magnesium carbonate. So 0.24. So 0.24, the half of 0.24 is, what is half? 0.12, right? So most probably 0.12 dm cube is being produced by each reaction. So total is 0.24. Did you get it?
Yes, Miss, got it.
Yes. Okay, so that is why I divided the number of moles by 2. Okay, but let's see. Now, number of moles of, they want you to calculate the number of moles of carbon dioxide first. Okay, that's easy. They have given us the volume. Okay, so you divide the volume by 24, and both are in dm cube, so no need to convert. So the same formula you can use, the number of moles of a gas is equal to the volume of gas divided by 24. Okay, so you get 0.1 moles of carbon dioxide. Okay.
Miss, you get 0.01 moles, not 0.1.
Okay, let me check. 0.24 divided by 24 is, okay, thank you. Yes, 0.01 moles of carbon dioxide. Okay. Now, number of moles of calcium carbonate and magnesium carbonate. Okay. Number of moles of calcium carbonate and magnesium carbonate. Now, can you see, in according to the equation, the ratio is 1:1. Okay.
Yes, Miss.
Yes, 1:1. So this will also be, so and का क्या मतलब मुझे समझ नहीं आई. Are they asking combined, or are they number of moles?
Combined.
Okay, if
Combined, Miss.
okay, if they're asking combined, then it has to be 0.01. It has to be 0.01, because this is also combined total, both the reactions. Okay, so 0.01. Now, number of moles of calcium carbonate alone, then I divided that by 2, because this ratio is combined. Okay, so the total is 0.01. Okay, so the number of moles of calcium carbonate, because I'm using the number of moles of carbon dioxide, so I divided by 2. Yes, Yusra?
Miss, like when you, for the first step, you wrote, how did 24 become 0.24?
Because 0.24 is the volume of carbon dioxide mentioned in the question.
Okay, Miss.
Yeah, that was the volume of carbon dioxide produced. Okay. So did you understand, Zainab, why I
Yes,
divided?
Miss, I got it. Yes, I didn't know that the carbon dioxide was for both. So I was like, shouldn't the number of moles of calcium carbonate and magnesium carbonate
Yeah,
0.
so because there are 2 reactions, and so they are giving you the total volume of carbon dioxide, the number of moles that we calculate from that volume is going to be the total number of moles. Half of them are being contributed by calcium carbonate, and half of them are coming from magnesium carbonate. Okay, so so the ratio is, halfened. Did you understand? So, okay, question part 2. Calculate the volume of hydrochloric acid. Okay, calculate the volume of hydrochloric acid, 1 mole per dm cube needed to react with 1 tablet. Okay, now 1 tablet meaning both of them, both calcium carbonate and magnesium carbonate are present in a tablet. So first of all, they want you to calculate the number of moles of calcium carbonate and magnesium carbonate in one tablet. Use your answer to C part 1, meaning this answer. This, they want you to use this number of moles. Okay, this number of moles. So calculate the number of moles of calcium and magnesium in one tablet, which is combined. Okay, so this was wrong. 0.01. Okay, so this will also be changed. 0.01 divided by 2.
0.0015.
0.0123. Yes, 0.005. Right. Okay, so number of moles of this is 0.01 moles. Okay, and then using this, number of moles of hydrochloric acid needed to react with one tablet. Now you can see the number of moles of according to the equations, according to the reactions. Please pay attention on to the question. Okay, in the worksheet you can see the total number of moles of hydrochloric acid is 4. There are 4 moles of hydrochloric acid needed to react with one tablet. Okay, so the ratio is 1:4. Okay, and so for 0.01, we will use that ratio. 0.01 multiplied by 4 will give you 0.04 moles of hydrochloric acid. Okay, so this is how. So now the volume of hydrochloric acid needed to react with one tablet. Okay, so the concentration of this is 1 mole in 1 dm cube. So 0.04 moles will be in how much? 0.04 multiplied by 1.04 dm cube. Do you have the answers to these questions?
Miss, for this part, I have for part C.
Okay, what is it? What are these answers correct? Check for me, because you know, because of this and thing that they have calcium carbonate and magnesium carbonate, I don't know what they want us to do.
For part 1, for the C part 1,
yes,
it is 0.01, then again 0.01, and then number of moles of calcium carbonate, it is 0.005. And then for part 2, the first one is 0.01, and then the second one, number
so
of
last answer is this: volume of hydrochloric acid is 0.04 dm cube.
No, miss, even the number of moles of HCl is wrong.
What is it? Are you checking the correct question, the correct year?
Yes, miss, the marking scheme.
Okay, so what is the answer to this? Number of moles of hydrochloric acid
needed to react with one tablet is 0.02. And then the volume of hydrochloric acid needed to react is
it 0.02?
Yes, miss.
Okay, so that means they have taken the ratio 1:2. That
yes,
means
miss.
they have, yes, the rest of the answers are correct, right?
Yes, miss.
Yes, so that means they have taken the ratio 1:2. So that means they, okay, they want us to, okay, wait.
Just like, why did you wrote 4? Because they're...
Yeah, because you see, because if you look at the equations, each mole is reacting with, each mole of calcium carbonate and magnesium carbonate is reacting with 2 moles of hydrochloric acid. So if you're considering, see, calculate the volume of hydrochloric acid needed to react with one tablet. The tablet has both, right? Tablet has both. Tablet has both calcium and magnesium. So each mole should give 2 moles of hydrochloric acid, right? So I don't know. Wait. I need to react with one tablet. Okay, I need to look into this. Okay, I don't know why they have taken 1:2.
Miss, we actually did this part This question C with
but
our
you know,
teacher.
are you sure you're checking this correct question?
Yes, miss. Yes, miss.
Okay. Okay, can you please share this answer with me? Okay, share this
Okay,
answer.
miss.
Okay. Okay, let's move on.
On group, okay? I'm sending on group.
Yeah, okay. Question number 7. Sorry, this is 7. May, June 2004. So this is page number 5. Okay. First is define mole. What is the definition of mole? You know that, right? Let's move on. B, part B is 3 grams of magnesium was added to 12 grams of ethanoic acid. Okay, and then we have this equation. The mass of 1 mole of magnesium is 24 grams. So that's the relative atomic mass of magnesium. Ek minute. Wait. Excuse me. Okay. So the mass of 1 mole of ethanoic acid is 60 grams. And then what are they asking? Which one, magnesium or ethanoic acid, is in excess? You must show your reasoning. So I told you sometimes they ask you which one is in excess, right? So how will we find out now? Which one, magnesium or ethanoic acid, is in excess? You must show your reasoning. The mass of 1 mole of magnesium is this. Okay. So now in the question, they have told us that 3 grams of magnesium was added to 12 grams of ethanoic acid. Now we have this equation. We know the ratio. This is ethanoic acid. Okay, the ratio is 1:2.
Sent, miss. I've sent.
Okay, the ratio is 1:2. Okay, now we will find out the number of moles of both magnesium and ethanoic acid. And we will see if they are according to this ratio. Okay, whichever of these values is above this ratio, that will be in excess. Okay, number of moles of magnesium, the mass they have told us in the question is 3 divided by its atomic mass, which is 24. Okay, so we get 0.125 moles of magnesium. Okay, number of moles of ethanoic acid, again, mass is given in the question, 12 divided by its relative formula mass, which is 60 grams, we get 0.2 moles of ethanoic acid. Now we will use the ratio. You can use any one of them, whichever you feel comfortable with. You write down the ratio 1:2. 1 is for magnesium, 2 is for ethanoic acid. Okay, and so I am using magnesium. So I use this value 0.125. I find out according to the ratio, how many moles should we have according to this ratio. And so I found out that I should have 0.25 moles of ethanoic acid according to the ratio. But what am I getting? I mean, how many moles do I actually have according to the question? This is according to the ratio, but according to the question, how many do I have? 0.2. So which one is greater? Which one is greater?
0.25.
This is greater. That means according to the ratio, I should have more, but I have less than that. Did you understand? According to the ratio is 1:2. So if I have 0.125 moles of magnesium, I should have 0.25 moles of ethanoic acid for all of these moles to react. But I have less. So that means ethanoic acid is a limiting factor. It is not in excess. It is not in excess. If this is not in excess, that means this is in excess.
Miss, I don't get it.
Okay, wait.
From
Let
the
me finish.
like,
Let
how do
me
we find
finish.
it?
Sorry?
How do we find the excess thing? I don't get this.
Okay, wait. Let me finish and then I'll do it the other way. Okay. Now, these are the actual moles that we have in the question according to the information given in the question. I used one of them and I put it down in the ratio to find out if the other one is less than or more than the ratio. Okay, this is less than what magnesium needs to react. For each mole of magnesium, you need 2 moles of ethanoic acid for this reaction to take place according to the equation. According to this equation, 1:2. The ratio is 1:2. Okay. So now, according to this equation, 0.125 moles of magnesium require 0.25 moles, but we have only 0.2. That means this is less than what magnesium requires to react. This is less. That means this is not in excess. This is less than what we require. If this is less, then that means this is in excess. Because remember, I told you the final product is always dependent upon the limiting factor. If this is the limiting factor, then this will decide the final product. Whatever the final product is, the mass of which will be decided by the number of moles of ethanoic acid, because this is less than what is required. There will be some magnesium left unreacted because 0.2 moles will react only with, in the ratio of 2:1. In the ratio of 2:1, half of these, they will react, half of 0.2 is 0.1. So they will react with only 0.1. Then you will have the rest of the moles left of magnesium. Okay, so that means magnesium is in excess and ethanoic acid is the limiting factor.
Teacher?
Yes?
Can I ask one question?
Yes, sure.
Which grade class is this right now?
Beta, this is not the time to ask this question. If you want to ask any question regarding this, ask that. Okay? Okay, in this reaction, yes?
Miss, can you explain why did you use the ratio method once you found out the 0.2 moles?
Sorry, can you please repeat your question?
Miss, then why did you use the ratio method when you already found out the moles?
Because the ratio method will tell me how these two substances will react. See, you can add the reactants in, you can add these reactants as much as you want, right? But in what ratio are they reacting? There is a specific ratio. So I want to find out what is the ratio. How are they reacting? Which one is the limiting factor and which one is in excess? For example, if you have 100 breads, okay, you can have 100 breads and you have 99 kebabs, okay? Now you can have as many breads as you want. You can have as many kebabs as you want, right? But how many burgers will you get at the end? That will depend upon the limiting factor. In what ratio are they reacting with each other? So 1 bread for 1 kebab, is that the ratio? For 1 bread, 1 kebab, you will get 1 burger. The ratio is 1:1. Okay, bread plus kebab, the equation will be something like this. Okay, so the ratio is 1:1:1. Okay, so if I have 100 breads, I have 99 kebabs, and I am getting 99 burgers. Okay, now the ratio will be, what is the ratio in which they are behaving? How will I, so the question is, the question told me that that you have 100 breads and you have 99 kebabs, but I will look at the equation to see, okay, I have 199, but what is the ratio in which they are reacting? 1:1. So 1 is left behind, 1 is in excess, this is in excess, 1 is extra. So only 99 will react with 99, okay, kebabs to give you 99 burgers. 1 is left extra. So in the same way, magnesium is reacting with that acid, ethanoic acid, to give whatever the product is. And the ratio is, what was the ratio? 1:2. 1:2. Okay, to give how much product? 1. Okay, so now, so magnesium is more than 1. For each 2, magnesium is more than 1. Okay, so magnesium is in excess. So I will calculate and I will find out their ratio. I will find out the ratio in which they reacted. Or, you know, the molar ratio, the simplified molar ratio is already given in the equation. That is why they write the equation, and that is why a balanced equation is really, really important. Okay? Did you guys understand?
Yes, miss. But miss, okay, yes, miss, got it.
Is this taught by the teachers?
Yes, miss, but yes.
But
It
what?
was taught. Nothing, miss.
Miss, we mostly use formulas. We don't use ratio, that's why maybe.
No, beta, this excess limiting factor has nothing to do with ratio or formula. I
Yes,
didn't
miss, we have
use.
to use the ratio over there.
Sorry? Oh, I use this ratio?
Yes, miss, so we have to use the ratio, isn't it? For limiting reagent and excess reagent.
See, even if you use formula, at the end, in order to decide which one is excess and which one is limiting factor, you have to do ratio. There is no other way. How
Yes,
will you
miss.
know? Yeah, all you can do is find this out by formula. All you can do is this. But at the end, once you have found out that it's 1.25, how will you know that this is, how will you know how many moles of ethanoic acid it will react with? You have to use the ratio method. You must have calculated this by formula, right? I have also used the formula. But then you have to use the ratio to find out how much of the other you require to react with this. There is no other way. There is no formula for this. Okay, when you have to find out the number of moles that are reacting with magnesium. Okay, you have to do a lot of practice. A lot of practice. The more you practice, and I would recommend you have the answer key with you. You have the answer key with you so that you know that your answers are correct. Okay? Okay. So, is there any question?
Miss, what if we use, instead of magnesium moles, we use ethanoic one, like 0.2?
Yeah, okay. Yeah, we can do that. Yes. Okay, so the ratio is 1:2. Okay, let's do it. Because I can feel you guys are really confused and you find this very hard, right? When I was a student, it was hard for me too. Okay, it is hard. Okay, magnesium, the ratio is 1:2. Okay, let's use the ethanoic acid number of moles. Now, ethanoic acid number of moles, according to what we have calculated, is 0.2, right? 0.2. Okay. Now I have to write it this way. Okay, ethanoic acid will, you know, the thing that you want to find out should be written on the right hand side. I write on the right hand side, it should be written on the right hand side. So now I am using ethanoic acid. I have to find magnesium, so I will write magnesium on the right hand side. Okay, ethanoic acid is 0.2. 0.2. According to the ratio, I should get 0.2 multiplied by 1. So how many moles will ethanoic acid react with? I'm trying to find that out. Okay, 0.2 multiplied by 1. So 0.1. How many do I have?
0.1.
1250. So this is the reaction. This is how much is required by ethanoic acid. But how much do I have? This is more than this. So I have, this is required. This is required by ethanoic acid. This is required. But how much do I have? I have more. So magnesium is in excess. So only, look at this, 0.1250 minus 0.1. What did I get? 0.0250. These many moles will be left unreacted. These are in excess, left unreacted. ये आखिर में बच जाएंगे. समझ आई?
Yes, Miss, got it. This means that if we subtract the real ones and the required ones, then if it is more, then it would be
Excess.
excess, and if it is less, then we'll get it limited. Means it is
Yes,
limited.
limiting factor. That's a limiting factor. Okay. Did you understand this? Can I move on?
Yes, miss. Yes, miss.
Ji, aa jaye. Ji. Okay. Now, how many moles of hydrogen were formed? So, how many moles of hydrogen? So, if we know, so, okay, another thing. When you know that a substance is in excess, you will not use its moles for finding out the number of moles for other substances. Okay. Whatever is extra, you will not use that substance, that number of moles to find out, you know, like how we use the ratio method to find out the number of moles of other substances, that you can.
Yes.
Yeah, so if a substance is in excess, so I cannot use magnesium, because now I know magnesium is in excess, it is more than what is required. So this will not give me the correct answer. I will use the limiting factor, because this will decide the product. This will decide the product. Okay, so I will use the number of moles of ethanoic acid and use the ratio. The ratio is 2:1. Ethanoic acid to hydrogen, 2:1. So I have used this ratio, ethanoic acid to hydrogen. The ratio is 2:1. So ethanoic acid, number of moles I had was 0.2. 0.2. So hydrogen will be 0.2 divided by 2 is equal to 0.1 moles of hydrogen. Okay, so now I have the number of moles of hydrogen. What will be the volume? I will multiply the number of moles by 24 and I will get 2.4 dm³.
Got
Okay.
it, miss. Just the limiting part was kind of confusing, but we got it.
Yeah, and also remember this point. If a thing is in excess, you cannot use that number of moles, that substance's number of moles, to find anything else in the equation, because that is extra. Okay, so if I use magnesium here, my answer will be wrong. If I, instead of 0.2, if I had used 0.1250, I would have gotten wrong answer. Okay, don't do that mistake.
Okay, miss.
Okay.
Miss, did you share this on WhatsApp?
Yes, beta, I have shared this. I have shared this. Okay, now part C. Let me just finish this question. In an experiment 25, yes, this is the same question, right? Okay,
Yes,
in an experiment, 25 cm³ of aqueous sodium hydroxide, 0.4 mole per dm³ was neutralized by 20 cm³ of aqueous oxalic acid. Calculate the concentration of the oxalic acid in mole per dm³. So number one, they want you to calculate the number of moles of sodium hydroxide. Okay. So what reaction is going on here? This
Neutralization.
neutralization reaction.
Yes, neutralization reaction. Okay. When we use neutralization reaction to find out the concentration of either acid or alkali, what is that process called? When we use,
Formation of salt.
no, beta, when we use this neutralization reaction in the lab to find out the concentration, to find out the unknown concentration of any one of them, either the acid or the alkali, what is this process called?
Titration.
Sorry? Yes.
Is it titration?
Yes, it is called titration. Very good. Yes. Okay. So this is titration. Okay. Calculate the concentration. Okay. Calculate the number of moles. So that's easy. You can use your formula if you want. Number of moles is, what is the formula? Using molar concentration. Sorry. Molar concentration is equal to the number of moles of solute divided by the volume of solution, right? Number of moles of solute. Yes. So number of moles of solute is what we have to find out. So we don't know. volume of solution is 25 cm cube. So we will convert it into dm cube, divide by 1000.025 dm cube, and molar concentration is 0.4. So you multiply, we get 0.4 multiplied by 0.025. What do we get?
0.01.
0.01 moles of sodium hydroxide. Right. Okay. So I used formula for you guys. Right. Right. Okay. Then part 2, use your answer to part 1 and the mole ratio in the equation to find out the number of moles of oxalic acid in 20 cm cube of solution. So see, they are themselves asking you to use the molar ratio in the equation. Okay, so for you have to use the molar ratio in the equation. Okay, there are no formulas for it. Okay.
Yes, ma'am.
Yes. Okay. So according to the equation, the ratio of sodium hydroxide to oxalic acid is 2:1, right? 2:1. We know the number of moles of sodium hydroxide. We just calculated, right? We just calculated. So 0.01 moles. And so simple ratio method, I divided by 2 and I got 0.05 moles of oxalic acid. Okay.
Okay, miss.
So these many moles were in 20 cm cube. These many moles were in 20 cm cube. So when they ask you concentration, basically they are asking you the number of moles in 1000 cm cube or in 1 dm cube, right? Concentration is what? Concentration is the number of moles per dm cube. That's concentration, right? So when they're asking you concentration, they're basically asking you to find out the number of moles in 1 dm cube. So okay, let me use the formula because you guys can get confused. Okay, so what was the formula again?
Concentration equals
yeah,
to
okay, so
number
molar concentration, we have to find out the number of moles. We have the number of moles 0.005. Okay, I divided by the volume of solution, which is 20. So I will divide this by 1000.02. What do we get? That will be the concentration of oxalic acid. Did you understand? I use this formula. Molar concentration is equal to number of moles divided by the volume of solution. So number of moles of oxalic acid we calculated to be 0.005. I divided that by the volume of solution, which was 20 cm cube. Because it was cm cube, I converted it into dm cube by dividing by 1000. So I got 0.02. And so what answer do we get here?
0.25.
Mole per dm cube is the concentration of oxalic acid. कुछ समझ में आई या नहीं आई?
Yes, miss, got it. Miss, what
Okay.
if in the next part, suppose what if they ask us to convert it into mass concentration? So we'll multiply it by MR or divide it?
Multiply, beta, multiply. Multiply.
Okay, miss.
Why do we multiply, Zainab?
I don't know, miss.
You don't know?
No, miss.
That means
because I skipped the class because I was traveling at that time, so I don't know this.
no. But you told me that you have watched all my recordings.
Yes, miss, but this I didn't get this part as well from your side.
From my side.
Yes, miss, the recording and stuff from that side.